presume you're talking about part B, Mohammed. The first part's just a simultaneous equation with 3. Just checking that. So, yeah, unless you have questions about the simultaneous equation with 3, I presume it's just part B that you're looking at. So it says, given that x squared plus px plus 3 is a factor of ax cubed plus bx squared minus 11x plus r, show that bracket p bracket b minus ap bracket is equal to 11 minus 3a. Okay, so I've done it out here, and I'll talk you through that now. So, prove this. This is a factor of this. This is what it tells us. So what I do, if this is a factor of this, the way I do it, they don't do it in the solutions. I divide this into this. Again, x squared into this goes ax, multiply it out, and you'll see it obviously gets a tiny bit messy. But if you do it carefully, follow the steps. Ax times this is that, ax times this is this, and ax times 3 is this. Take them away, change the sign. Look, I have b minus ap x squared. That's where I get that. And 11x minus 3ax. 11 minus 3ax. That's where I get that. I bring down the or. Do it again. X squared into this goes b minus ap times b minus ap times b minus ap times this is this. B minus ap times this is this. Be very careful. And b minus ap times this is this. Then I take away, changes the signs. So I do 11 minus 3a minus bp minus minus becomes plus. So again, I just keep taking them down. It's starting to look messy, but don't worry, it will work out in the end. And then this minus both of these changes the signs. We end up with this. Okay, so for this to be a factor of this, this remainder must be 0, and it's not 0. So without even looking at what I want asked to prove just yet, I know that the x part must be 0 and the constant part must be 0. So I let this equal 0. 11 minus 3a minus bp plus ab, that must be 0. And the constant part, or minus 3b plus ap, that must also be equal 0. If I just go back, excuse me, I'm just going to go back and look at the question. It now says prove that p bracket b minus ap equals 11 minus 3a. So I'm going to work with this side. I'm going to get the 11 minus 3a on its own, and I'm left with this on the right. And if I just factorise that, that's what we're asked to show. Then the second thing you're asked to prove is 33 minus 9a equals PR. 33 minus 9a is PR. Now, I know it's going to be something to do with this, because 11 minus 3a, and I'm looking for my 33 minus 9a, so I'm going to keep this in mind. The only thing here, this b minus ap isn't in it. We're looking for an or. So there's an or on this side. So what I do with the constant side is I get or on its own, bring these across, and then I look back and I'm looking to get b minus ap. I'm looking to get rid of that b minus ap. Sorry, looking to get rid of this b minus ap. So if I get that on its own, in terms of or, I end up with or over 3 is b minus ap. And then I go back to this, and instead of this b minus ap, I replace it with or over 3. And I keep looking back at what I'm asked to prove. If I multiply this 3 up here, sorry, that's a mistake, that becomes 9a equals PR, and that's what we're asked to prove. Okay, tricky with the terms, but just divide in and it should be equal to 0. Again, show, if you're stuck, try and divide it in, and you'll get 4 to 6 marks, even if you don't get down to this part. Okay, the next question you asked me was the complex numbers, so just bear with me a second. Okay, so the complex number question, so it asks you to plot them, and usually plotting is easy, but when they're not given any numbers, it's not. But it tells you that Z2 is the conjugate of Z1. So remember, conjugate means they have the same real parts. So say if it was 2 plus 3i, the conjugate would be 2 minus 3i. So you're looking for two numbers, or two complex numbers, that have the same real part, but opposite imaginary parts. So they'd have to be the same. The only two with the same real parts are these two. Okay, the only two with the real parts. So these two have to be Z1 and Z2. Now, how we decide which one's Z1 and Z2? Because we look at the next one. Z3 is I times Z1. When you multiply a complex number by I, it's going to flip around, because the I is going to get multiplied with the imaginary part, become an I squared, change that to a minus, and then the I is going to stay with the real part. So what happens is the real parts, the value of the real parts is now the value of the imaginary parts. So it actually moves in a 90 degree. I think this is a part back, if you go back to complex numbers, it moves in 90 degrees this way. So there's nothing that this could be moved. So this can't be Z1, because if I move this 90 degrees this way, there's nothing there. But if I move this 90 degrees, it actually comes to this one. Now I haven't drawn them accurately. So that means this one must be Z1, this one must be Z2, and this one must be Z3. That's not to do with the question, that was just for you. So Z5 is Z3 plus Z4. So when I add two complex numbers, they're going to get pushed out this way, because Z3 is, say it's minus 1 plus 2i. If I add another minus, if I added that to it, this is before we know what these two are, if I added this to it, it would end up out here. So it must be this one. These two adding together must give us that. Okay, so this must be Z4 and this must be Z5. Going to the next part of the question, it says using binomial expansion or otherwise expand this. Now in the solutions in the book, what makes it complicated, instead of putting cos theta they just put c, and instead of putting sine theta they just put s. So I haven't done that because they were just being lazy. So I'm going to use binomial expansions. That means 3c0 times this one cubed plus 3c1 times this one squared times this one plus 3c2 times this one squared becomes I squared sine squared theta, that's a squared here, and then 3c3 I cubed sine cubed, so this one's not in the last one. Then that becomes 3, that becomes 1, that becomes 3, that becomes 3, that becomes 1, and your I squareds change to minus 1. So when you simplify this, this becomes cos cubed theta, this becomes plus 3 cos squared theta plus I sine theta. This one, the I squared changes to minus 1, that's where we get the minus 3 cos theta sine squared theta, and this I cubed becomes a minus 1, so this should be minus, but then there's an I there as well, sine cubed theta. Okay. And that's it fully expanded, and it said in the book it has c cubed plus 3c squared is, don't mind that, okay, I've left it as that. Then the second part says hence or otherwise, what does it? Does it say hence or otherwise? Yeah, hence or otherwise prove the identity. So when it says hence or otherwise, generally the easiest way is going to be using the previous part. So what I've done is, that's what you're asked to prove. Hence or otherwise, this is what we worked in the last one. We said that this was equal to this, and that's good because there's a cos 3 theta. And when I expanded this from my previous part of the question, I got this. So I know this is this. So that must mean that this is equal to this. And from that, because look, we only want to deal with cos, we don't care about the sine 3 theta. This is the real part. There's no I there. So the real part here must equal, this is a real part. That's not a real part because it has an I, but this is a real part. So this must equal this and this. So that's what I do in the next line. Cos 3 theta is equal to this minus this. I look back at what I'm asked to prove. It looks very similar. We have a cos cubed theta, we have a cos theta, we have a sine squared theta. We want to get rid of this sine squared theta. So going from our trig tables, sine squared theta, remember, sine squared theta plus cos squared theta, I think it's on page 13 up the top. Sine squared theta plus cos squared theta is equal to 1. So remember, you can rearrange that. This can be replaced with 1 minus cos squared theta. And when I multiply out that bracket, I get minus 3 cos theta times 1 is that, minus 3 cos theta minus that is plus 3 cos cubed theta, and in this collect like terms, 4 cos cubed theta minus 3 cos theta, and that's that. With question 5 that you asked me, Mohammed, I think, no, that is an error. I don't think they meant to put that question in, so I'll attach the real question. That was an error and I meant to point that out to you. That first part, I presume, is the one that you're looking at, the ln of 1 plus x over 1 minus x. That's that wasn't meant to be the question. So I'll send on the real question now. But if you have anything else about that question, please let me know. Or if there's anything about any of these you don't understand, please let me know.